In your exam, you will definitely be requested to answer these sorts of questions here. Now, these are questions where they give you the original function and then they say what would the differential function, the same function after we've differentiated, what would they look like on a set of axes? Well, I'm going to show you exactly how to do those here. So the first one we've got is f equals, so f of x or y equals 2x plus 3. Okay, if we were to differentiate that, what would we get? The 3 is going to disappear, the x is going to disappear, and we're going to be left with 2. And in fact, I've got it right down there. So this line here is 2x plus 3. This line here is y equals 3. This is this differentiated. Now, notice something interesting. The gradient never changes. It's always 2. And it kind of makes sense. In a straight line, it goes in a straight line. The gradient doesn't change. The gradient is always 2 over 1. We go across 1, we go up 2. We go across 1, we go up 2 forever and ever. So on a straight line like that, the gradient will always be a straight line parallel to the x-axis. So far, so good. Okay. We have 3x squared minus 4x plus 2. And it's a parabola that looks like that. Now, from infinity down to here, what do we notice about the gradient? It's negative, but it's getting less and less and less negative until it reaches a turning point there where the gradient is 0. And then if we start going to the right again, it starts off slowly, but then the more and more that we go across, it gets steeper and steeper and steeper. All right. What do you think if we differentiate that equation, 3x squared minus 4x plus 2, if we differentiated it, we would get 6x minus 4. And that looks like that. And if you think about it, this is kind of makes common sense. Out here where g was, say, x equals 1, this thing is really, 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 really steep. But it's sloping negatively. Therefore, it's a really, really big negative slope. And directly under that is a very, very steep slope below the x-axis. And notice it becomes less and less and less and less and less steep. So therefore this gets closer and closer and closer to 0. When there is no slope, the slope is 0. That means that this line kind of breaks through the x-axis like a shark jumping above water. And then as we keep on going on the original equation, it starts becoming steeper and steeper and steeper and steeper and steeper. Therefore, this will just also get bigger and bigger and bigger. As the steep goes up, this line will get further and further up. So, At a turning point, the first difference equation will always cross the x-axis because the slope is 0. There is no slope. If the function is facing downwards, it's sloping downwards, the gradient must be below 0. So this means it's very, very steep, less steep, less steep, less steep, less steep, less steep. In fact, at this point, there's no slope, and in fact, it starts becoming a positive slope from there on. You will be asked to draw these in your exam and make an inference, make a comment on what they are. Last example, we have 2x to the power of 3 minus 2x squared minus 4x plus 4. And it gives us this kind of n-looking graph here. Okay, so let's kind of go from left to right. Here, the slope is going to be very, 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 very steep. Is it going to be a positive steep or a negative slope? It's going to be a positive slope because the man walking from left to right will have to walk up a very, very, very steep cliff face. So, therefore, when we differentiate it, that function that we create from that difference function should be up here. When x is 2 for the original equation, this must be up here to show that it is very steep. Then, as this gets less and less and less and less steep as it reaches this turning point, the gradient must also come down and approach 0. And it's going to approach 0 directly underneath the turning point, because the x value for the turning point, the gradient must be 0. So our line is going to kind of go there like that and hit the x-axis where the gradient equals 0. And then from here to here, the gradient is 0. So this line must also be under the x-axis. But notice what happens here. It starts getting less and less and less steep, negatively sloped. So it's going to start moving back towards the x-axis. Is still negatively sloped, but it's not quite, and just at the point where it turns and the gradient is 0, it's going to be at that x-axis. And by the looks of it, this goes up. The slope now starts going up. So it's going to go through the x-axis and it's going to also start going up. And in fact, it's looking steeper and steeper and steeper. So it's going to keep going up to match that. And this is in fact what that looks like. So the black graph is the original function. The f dash of x, or dy dx, is this function. So we start there, very, very steep. We don't care where it is in respect to the x and y. We only really care how steep it is. Very, 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 very steep. And then it gets less and less and less, less and less and less steep there. So this comes down and down and down. The turning point is here, and directly below it, it crosses the x-axis, because the x-axis equals 0. So therefore there's 0 slope right above it. And then it's negative because from here to here, it's negatively sloped. Remember, our man is now walking downhill, negatively sloped. And then it starts getting less and less and less and less steep until it gets to a turning point and it goes back up again. Study these. You will use these in your exams. You will need to draw them in your exams and be able to show that you understand what they mean. And in fact, here's one from the 1921, the 2021 exam. So it says here the graph of the function y equals f of x. So that's our original function. Sketch graph to show f dash of x. Okay, well, let's work it out. So the gradient from here to here is negative. So if we sort of go down here, it's there. It's going to be negative, but it's going to be less and less negative. And where it crosses that x-axis, right below, right there, must be a turning point. So the turning point, the gradient is 0. So negative gradient. And then from here to, looks like the y-axis, it starts off small and then gets very steep and then it kind of cutters off. Okay, so it's still positively sloped. So it's still going to be positively sloped, and then it gets a little less. Start getting less and less until it crosses the x-axis there. I think this drew a line here. Am I going to be able to get rid of that? I think it drew a line. What is said? Oh, I see you're trying to draw a line. It goes like that. And then it becomes negatively sloped. So it's going to move down here until it gets to a point where it is negatively sloped. So it's getting less negatively sloped, and then it goes above there. Everything from this point on is positively sloped. Therefore, this, when we differentiate it, it must be a positive number. Everything from here to here must be below the x-axis when we differentiate it, and indeed it is. Or here, that's negative, that's below the x-axis. From here to here, it's positively sloped, so that must be all above the x-axis, and everywhere on from here is negatively sloped, so that must be, all of that must be below the x-axis. Practice with some, write some out, sketch them. Once you get it, it's not too hard to do those.